All right. Check Zoom one more time. The student. Oh, we got a lot of people that are like dragging their feet today. Okay. So I'm gonna go ahead and share my screen, start the broadcast, and we'll start here. All right. So welcome, scholars. Let me see. No major announcements. It's just the usual stuff. You know, this is the end of week 10, so we can anticipate during week 12 will be exam 3. I think it's covering chapter 2, so 2.1, 2.2, and 2.3. So today we're just going to continue working on section 2.2. Polynomial function. I think when I work with my students from earlier, I didn't have to write anything, like take notes or anything. So, and I'll check attendance again around the 15-minute mark for people that come late. So we have this polynomial. We're asked to write the degree of the polynomial, the leading term, the leading coefficient, and the constant. Can anybody tell me the degree of this polynomial, right? The degree is going to be what? The variable, the term with the highest exponent, or is going to be the highest exponent? So the degree in this case should be 5. Okay. The leading term, right? So what's the leading term of this polynomial? Should be 2x to the power of 5. So then if that's the leading term, then the leading coefficient is 2. And the constant term. The constant term is a term that has no variable associated to it, so that's going to be our -6. Okay. The degree, right? The degree is going to be the variable with the highest exponent, or the highest exponent on any variable, which is in this case is going to be 3. Okay. The leading term. So the leading term is a term that has the highest variable, the highest power. It normally would be 2x cubed, but because we're dividing by that 7 in this fashion, you can distribute that 7 into the top, onto the left and the right. So then instead of 2x cubed, it's going to be 2 over 7. 2 over 7x cubed. Okay, let me zoom. Let me leading coefficient is 2 over 7. And again, if anything isn't clear, just feel free to unmute yourself to get my attention, and we can adjust. For the following polynomial, let's see the time. We'll give people another 10 minutes to get into the waiting room. Okay, the degree of this polynomial, so the highest exponent in this case is going to be 3. The leading term is going to be that 3 pi x cubed. So 3 pi x to the power of 3. The leading coefficient is going to be 3 pi. Okay. Okay, so I'm going to do a poll for this one. Let's see, that's kind of been working kind of like that. I think I need to zoom out some. Okay, and let me check Zoom. Let me see. Look at these two. Okay. Let these two in, and I want to do a poll for this one, right? So let's do a poll. General multiple choice and launch. So is it A, B, C, or D, right? Why is this one not a polynomial function, right? Is it A, is it B, is it C, or is it D? What do you think? All right, okay, there's a vote for B. Let's see. It says the function is not a polynomial because of the presence of absolute value of x. I can get down with that. So let's submit that one. Let's see if I hit enter. Okay, that was good. Okay, cool. Let's go to the next question. I could do something like that. I could do some things, but I don't know. I might save that for another time. Determine if the following function is a polynomial function. All right. So I think we can do multiple choice here as well. Let me relaunch this poll. Launch. So is this one A, the first choice, or B, the second one? Is it a polynomial or is it not a polynomial? So you got 50-50, even if you guessed. Okay. Right. I think it's B, right? Let's go with B. Because, for instance, if you were to distribute that denominator into the top, the first term is going to turn into 1, right? But then the second one, you're going to get 3 over x squared, which is the same as 3 to the power of negative x. Negative 3x to the power of negative 2, right? So you can't have a negative exponent if it's to be a polynomial. So because of that negative exponent, it's not going to be a polynomial. Okay, let's try another one. Yeah, let me relaunch the poll. Launch. Okay. Explain why the following function is not a polynomial function. All right. Is it A, the function is not a polynomial function because of the presence of the square root of x to the 5th? Is it B, the function is not a polynomial function because of the presence of 9x to the 4? Okay, there was one vote for A. I can get down with A. The function is not a polynomial function because there is no constant term. That's not it. The function is not a polynomial function because there's no x term. I'm gonna go with A. I can get down with A. All right, that looks good. Okay, let's keep going. Let me check something. Let me let him in. Right here. Okay, let's keep going. But our polls and quizzes. Let's relaunch this poll. Okay, launch. Is the graph, it's only 2 choices, A or B. Is it a polynomial, yes or no? Right. So remember, I think last time there were 2 properties that we said for the graphs of polynomials. The first thing that we said was that the graph is continuous, which means there are no breaks or gaps or holes. And then the second one was that the graph is smooth. So there are no sharp corners or edges, right? So I think we do have a gap or a break. So because there's a gap or a break, it cannot be a polynomial. So is it a polynomial function? We're going to say no. All right, it's not a polynomial. Okay, let's try the next question. What about this one? Let me relaunch this guy. Okay. So is this a polynomial? Can you see? That's enough information, right? So is this graph a polynomial function? Is it A, the function is not a polynomial because the graph is not continuous? Yeah, I think we just said that. The function is not a polynomial because the graph has a curve? No. The function is not a polynomial because the graph is, no. The function is not a polynomial because the graph has a straight line. No, it's A, right? Okay. I feel like there should be like only 2 people getting attendance credit today. The only reason I haven't like started invoking stuff like that is because the agreement was, this is what we agreed upon, and I just haven't been pressing the matter. But I'm kind of having like essentially the same 2 people engaging. Let's relaunch. But I feel like as long as at least like 1 or 2 people are getting it, then that puts me at ease. That puts me at ease. Because then it's just like, okay, well, if you're not going to get it from me, I know that there's at least 2 people in the class that are getting it that you guys can work together with. Let's go on to the next question. Or the tutors or somebody like that. Match the following polynomial with the graph. Okay, so this one's not multiple choice. Let me just end this poll for right now. And suppress that. Go like this. Come on. with this graph. Okay, so the y-intercept. To find the y-intercept, we set x to 0. If we set x to 0, the output is going to be 0. So I'm just going to put 0 for now. Okay. So we got our y-intercept, right? Now, if we look at, so now we're back to multiple choice. So, yeah, let me launch the poll. Launch. So is it A, is it B, is it C or D? Now, when trying to identify the correct graph based on the leading term test, the leading term in this case is a negative x to the power of 8, right? So then if we look at the leading coefficient is -1, which is negative. So that means our graph should be going down to the right. So so if our graph is going down to the right, that automatically knocks off B and C because those go up to the right. So it can't be B, it can't be C. So then we look at the degree of the polynomial, in this case is 8, because 8 is even. That means the other side of our graph is going to do the exact same thing. So if we're going to go down to the right, that means we're also going to go down to the left in this case. And I think there's only one case where we go down to the right and down to the left. Yep. And it is A. Yeah, let's go with it. Okay. So I'm just trying to give you a little context for anybody that's listening, as to why. It's less about having the right answer and it's more about why is that the right answer, right? That's what a lot of it is. Let me get the student. So, I mean, you can get the answers, but then, if you just ever find yourself in a testing environment and you can't get the answer on your own, you don't know why that's the answer, then, it doesn't serve you. This isn't to get the answers and to get credit. Do what you got to do. I get it. But the real thing is, why are these the results? Why is it the way it is, right? And I think it's a fool's errand to think that you're never going to see this again and to think that you're never going to be in a testing environment. Like, I don't know when it'll happen. Right now it is very lax, but if it doesn't happen even like here at the school, I mean, I have so many students that like they leave and then they come back years later. They're like, Professor Phifer, I went to this job interview and like I got out of your class and they were like, oh, I'm so excited. I never had to look at math again. I even have a friend right now. She's putting in applications. I'm gonna just submit A because somebody went with it. I hadn't even read this one. Awesome sauce. I'm gonna go ahead and go with that one. I'm gonna relaunch the poll and go on to the next question. But yeah, she's putting in applications right now. And I mean, so many of these applications are giving her like math questions, math exams. Okay, so this one's not multiple choice. So I'm gonna end this one. So yeah, sooner or later, you're gonna be responsible for this stuff. I'm not mad at you, just do what you gotta do, but try to get something out of it. Don't just like, finesse the whole thing. Like, you know what I mean? Because sooner or later that's gonna catch up to you. And you don't want something like this to get in your way. Match the polynomial function with this graph. Okay, I think we're gonna have multiple choice in just a moment. The y-intercept, right? To find the y-intercept, we set x equal to 0. If we set x to 0, the output is 7. Okay. And then still multiple choice. So we're going to go like that. Are you sure you want to? No, I don't want to leave. There we go. Let me launch the poll right here. I think I checked the thing already. Let me just check one more time. Yeah, we're good there. Let me launch this guy. General multiple choice. Okay. So based on what's shown, we have this polynomial that's shown. Is it A, B, C, or D? All right. Is it A, B, C, or D? So I'm going to kind of yammer a bit until somebody chooses, and I'll go with whatever you choose. I mean, I think I said what I needed to say with that other thing. So just do the best you can, and it's okay. You just try to get something out of it. You're an adult now. You have to make decisions for yourself, and you need to be accountable for yourself. So what that means is that whatever the result is, you gotta own it. You know what I mean? Like, if it works, you deserve the glory. But if it goes sideways, you could blame whoever you want, but you're an adult. You're responsible, right? Let's go with D because somebody chose it. I'm going to just kind of go with it. Let me see. Okay, awesome. That was awesome, right? And like I like what we're doing in this context, in that whoever, whoever's the most interactive, whoever is doing the most talking is doing the most learning, and they're the ones that's getting it. If I'm doing all the talking the whole time, that means that's the only reason I'm good at it, because I've been talking about it day in and day out. Not that it's, I mean, this language is more about construction and like planning, right? This is like the language of planners and builders and engineers and things like that. People that, let me see. Okay. I mean, we can, if somebody's trying to improve the overall grade, right? I generally say the same thing to everybody, where if you're trying to improve your overall grade, my recommendation is to go back and improve your exam scores. Just do that first. The exams count for nearly 80% of your overall grade, right? So that's where the bulk of your points come from. The homework and quizzes, those are really just there to prepare you for the exams. At this point, we're past exam 1 and 2. You can still open them up, and you can earn all the way up until a 90% on those assignments. You can take those assignments and sit down with the tutors or whoever and say, hey, can we go through this and improve my score? So then when I go to calculate your grade at the end of the semester, it'll show. That's when it's going to show, right? That's the nature of the way this is set up. It's just sitting there waiting for you to kind of make a plan and to get it done. But I intentionally made these assignments so they have unlimited attempts. I intentionally set it to a minimal late penalty to encourage, people to like try. A lot of this, if you just put forth a genuine effort, that'll cover the bulk of what you're trying to go for, right? Not everything. It's not going to get you all the way there, but it'll cover the bulk of it. If you're not even really trying, then I don't want to waste your time, and I don't want you wasting my time. You know what I mean? But if you just try, that'll cover somewhere between 60 and 80% of what you need. And then you're gonna have to push a little bit more, but that should cover the bulk of it. But again, if you are trying to improve your overall score, if you don't do anything else, make sure your exam scores are as high as possible. And then from there, if you have the energy and the patience and you have what you need, you can always go back and improve. I would do quizzes next after my exams are in order. And then once I'm done with the quizzes, I will go back and improve homework. Homework is a lot of work for a little bit of points, right? So the homework will take you like hours and hours and hours, and you won't see a shift in your grade. But if you like get really good scores in your exams, you'll see your grade point jump by like points. So that's what I would say for anybody that's trying to improve the score at any stage. Okay, let's take a moment to, let me see. We're doing pretty good. We're about halfway. Let's keep going. So for the polynomial function below, first we're asked to list each real zero. Okay, let me do this disclaimer on this one. So I know we got through as much of the lecture as we could on Monday. We did what we could together on Monday, but I think we only made it about halfway through the lecture. This is a question that comes from something from the second half of that lecture, right? So it's important. That's why I made those pre-recorded lectures, because I know that together we're not going to have a lot of time together. So you do have to work on your own outside of this time. If you watch my pre-recorded lecture, I actually go into explaining multiplicity and this kind of thing in the full lecture. I'll do what I can here, but this isn't the only concept that's hidden in the homework that you're responsible for. So we might not talk about it exclusively together, but you're still responsible for it. So it's in my videos, it's in the homework. More than likely, it'll pop up on the exam at some point. Okay. All right. So list each real zero in multiplicity, right? So we got fortunate with this one in that it's already in factored form, right? So if we wanted to find the zeros, we would set this to 0 and solve. We can use the zero factor property, which states that when you have 2 or more things that multiply to give you 0, you basically set each thing to 0 and solve. So from this middle factor, this x minus 8, if we set that to 0 and solve, we get x equals 8. And the other one is negative 8, if we were to solve that. Okay. So the first 0 is x equals 8. Okay. And we also have negative 8. So let's do negative 8. Okay. Okay. So then the next part is the multiplicity. So the multiplicity of 8, it comes from the exponent, right? It comes from the exponent. So the 8 came from this middle one where we have the x minus 8. The power there is to the power of 1, right? There's an implied power of 1, so the multiplicity there is 1. Okay. But then the negative 8 came from that trailing binomial factor. So where we have that x plus 8 squared, that 0, that's where the negative 8 comes from. And because of that power of 2 is the multiplicity. In the one before, the power is to the power of 1. But this one is to the power of 2, so the multiplicity is 2. All right? Okay. So then the next part, so because the multiplicity when x is 8 is 1, which is odd, that means that when we look at this graph, it's going to cross the x-axis when x is equal to 8. So it's going to cross the x-axis when x is equal to 8. Okay. And then because the multiplicity when x is equal to negative 8 is 2, which is even, that means the graph is going to bounce off the x-axis when x is negative 8. Okay. That was a mouthful. It's not intuitive. Like the only way you would know something like this is by going through the homework and it pops up and it's brought to your attention. But like, if you were on a test and you had never seen that before, that's not something that's obvious. It's something that comes out through basically research and exposure. All right. Okay. For this polynomial function, same kind of deal, right? So we can go a little bit faster. So the zeros we're fortunate, it's already factored, right? So we could set each binomial factor to 0 and solve. If we set them to 0 and solve, we'll get 8 and negative 4. Okay. And just stop me if anything is not clear, if I'm going too fast or anything like that. So the multiplicity of 8, you're not going to do the thing? Okay, this is fine. So the multiplicity of 8 is 3. You can see that power of 3, so the multiplicity is 3. Okay. The multiplicity of negative 4 is going to be 2. It's not letting me reach. Because the power is 2. All right. Okay. So for the x-intercept of 8, because the multiplicity is 3, which is odd, that means our graph is going to cross the x-axis. Okay. When it has an odd multiplicity, it crosses the x-axis. When it has an even multiplicity, it bounces or it touches off it hits the x-axis and turns around and goes the opposite direction. So if we were looking at the graph of these, it would cross the x-axis when x is 8, and it would bounce off the x-axis when x is negative 4. Okay. Maximum number of turning points, right? So let me see the time. So with the number of turning points, if you think about like y equals x squared, which is a parabola has at most 1 turning point, right? If you think about y equals x cubed, with some other manipulations, the power of 3, it can take on the S shape, right? It can have a local max and a local min, and it can take on the S shape, but it has at most 2 turning points. So the turning points is going to be, you have at most n minus 1 turning points. So if the degree of your polynomial is n, then you have at most n minus 1 turning points. So the max number of turning points that we have here, the degree of this polynomial, if we were to expand this guy all the way out, at one point we would have an x to the power of 3. At another point we would have an x squared, and we would end up multiplying those guys. So x cubed times x squared is going to be x to the power of 5. So since the degree of the polynomial is 5, that means we have at most 4 turning points, n minus 1. Right? So not obvious. I go into greater detail in the full lecture. I'm just talking about it because it popped up in the homework. And we were not able to finish earlier, so there might be some stuff towards the end that you might need to know as well. Determine the real zeros. Okay, so the zeros, again, we're fortunate here, it's already factored. Let me see. I think that second one, negative b plus or minus root of 4 times a times c. Let's see, b squared, so that's going to be a 1, square root of 17. Radicals as needed. I think I need to write this one out. I was trying to avoid it, and I didn't write it out earlier, but it got kind of sloppy. Let me check Zoom really quickly. See if we got any scragglers. I get him. Got him. Got him, coach. Okay. So let me get a copy of this. Get a copy and take some notes here. Let me zoom in just a little bit. So let me take this and we're going to drop it over here onto notability. Okay. Let's go like this. And let's bring that back. Okay, I think this is good. All right, so I just want to check something. So I want to use the quadratic formula on that second term to see what happens, right? So the quadratic formula. So some of my students of the past, they showed me the way that they remember the quadratic formula. They showed it to me. It put a smile on my face. I was like, oh, that's interesting. So what they share with you, I'm going to share with what they share with me. I'm going to share with you now. So the way they remember the quadratic formula, they'll do the following. The negative boy couldn't decide to go to the radical house because he was square, so he missed out on 4 awesome chicks, and it was all over by 2 a.m. All right, let's do that one more time. That's how they remember. I was like, dang, I really like that because it was like a movie, right? And so to me, it reminds me of the movie Hangover, right? But that's how they remember it. And they told me maybe once or twice. I was like, it was locked into my memory then because the story was so zany, and it was just a fun way to remember that formula. So then it's like, well, maybe you can make up something like that for other formulas that are like a challenge to remember. And like, see, that's the techniques you can use if you were going to like med school to remember stuff. That technique is called the memory palace. And what it is you have a list of things that you want to memorize. And so with each item, you associate it with something that's as zany as possible inside your memory palace. So the more zany the thing is, the easier it is to remember whatever it is you're trying to remember. And there are competitions where people, they use this technique. I mean, they remember like some crazy stuff, like everybody in the audience from like hundreds of people. They'll meet them once and they'll like, it's wild. But the technique that we're describing again is called memory palace. Okay. So again, the way this memory palace technique went for the quadratic formula, the negative boy couldn't decide to go to the radical house because he was square, so he missed out on 4 awesome chicks, and it was all over by 2 a.m. All right, little movie, mini movie. Okay. So I just wanted to do the quadratic formula on that second factor. Okay. So then if I use a quadratic formula there, let me see. That's going to be 1 plus or minus the square root of 1 minus 4 times 1 times negative 4. Okay. All over 2. All right. Okay. 1 plus or minus 16 plus 1 is 17. 2. All right. So the zeros we get from that trinomial factor is 1 plus or minus the square root. 1 plus or minus the square root is 17 over 2. All right. So now I think we have what we need to go back and answer the question. So the zeros, so we have 2 things that multiply to give us 0. So by the zero factor property, we set each thing to 0 and solve. So then x squared equals 0 is just going to give us 0. So that's just 0. And then from the other one, we got I think it's 1 plus or minus the square root of 17. So let's comment is here. So on top, we have 1 minus the square root of 17 over, I guess 2, comma. So we did the minus, and then let's do another fraction. Put our comma here. And this was supposed to be 1 plus the square root of 17 over 2. Okay. All right. For some reason, I have this urge to launch into the story about liking math, right? I do acknowledge that most college algebra students don't like math, right? It's not everybody. But I found myself like, I had this like Uber client and I was asking her, well, do you like math? And she was like, no. She was like, I only use it out of necessity. I was like, well, do you like money? She was like, no, I only use money out of necessity. And so I got caught up on that. I was like, well, if you don't like money, I'll take it. She was like, no, I'm gonna keep it because I need it, out of necessity, but I don't like it. She was like, if I didn't have to use it, I wouldn't use it. But for some reason, I thought about that conversation earlier and I was like, well, I kind of wanted to ask her, do you like anything? Because if you like anything, as far as I'm concerned, everything is an expression of math, right? You can take anything and relate it to in mathematical terms. It's just that math is just another language. It's just another way of saying the same thing. You can look at, I don't know, the sky being blue, and in one context you say, oh, it's a blue sky. In another context you say, oh, the light that's being reflected is, all the light is being absorbed except for blue, which is being reflected. So that's the wavelength that's coming off. There's so many different ways that you can describe the same thing. So math is just another way of articulating everything, right? I don't know why I launched that. I just did it just because. The multiplicity of the zero located furthest on the left. Okay. So if zero's in the center, we have that plus or minus. So the multiplicity of that is coming from that trinomial, the x squared minus x minus 4. But that had two zeros. One was plus, one was minus, and each one occurred once. So that means the multiplicity of each of those from the plus or minus is 1. So we're going to put a 1 here. Okay. And what that means is that, so the middle zero, let me see. So the middle zero is going to be the origin, and that one has a multiplicity of 2. Okay. And then I think we said that the far right one should also have 1. So it goes like 1, 2, 1 in this case. Okay. So then what these multiplicities mean, that leftmost zero, because its multiplicity is 1, that means it's going to cross the x-axis. Okay. That middle zero, because its multiplicity is 2, which is even, that means it's going to bounce or touch the x-axis and turn around. Okay. And a similar argument for the rightmost, because it occurs once, the multiplicity is 1, which is odd. That means it's going to cross the x-axis. Okay. So this whole business on multiplicity is not obvious. The only way you would really be aware of it is making your way through this kind of material. Let me check Zoom really quickly. You guys are hanging in there strong. Let me get the student. Okay. And I just let this student in. Okay. All right. So this is an application of the intermediate value theorem. We want to show that this polynomial has a 0 between 2 and 3. So when we introduced this concept, we said that, okay, because we're working with a polynomial and we look at the graphs of polynomials are smooth, continuous curves. So there are no holes or gaps or breaks. There are no sharp corners, edges, or anything of that nature, right? So then if we were to test these endpoints and pass them through our function, if one endpoint is positive and the other endpoint is negative, that means that somewhere between 2 and 3 on the x-axis, it has to cross the x-axis and it has to be a 0 somewhere between 2 and 3, right? So what we're gonna do, I'm gonna show you a couple of techniques here. There's like if I'm working on a TI 83 plus, oh, there it is. If I'm working on this 83 plus, okay, there's a quick way to go about this. If I go to y equals, I type in my x to the power, oh, I forgot. Okay, I'm trying to type it. X to the power of 4 minus, that's not minus. Let's divide. Log. Nope. Okay, let me just do this. X to the 4 minus, oh, what if I do it over here? Okay, minus 2. Now I got to find x. Because it's not that one. See if I can find it. That's 10. It's not those. That's squared. I don't understand. That's 8. Trying to see if I can find the x button. 10 close 7. That's math. What else can I hit? There it is. Oh, found it. Okay, let's start this over. Okay. I think I got it. So x, let me see if I hit shift this. Caret. All right, I got to find that button now. I'm trying to do my shortcuts. And I hit it somewhere. It's not that one. There it is. That'll work. H. Okay. Let's try this one more time. So xh to the x to the power of 4 minus 2x to the power, so hat cubed, okay, minus 11. All right, we're getting in there. Okay, yeah, this looks good. Oh, minus, right? X to the 4, and this needs to be a minus 2x cubed minus 11. Okay, so we put that in there. So then let me quit. I want to go to my table. So I want the table to start when at 2, and I wanted to change. Actually, let me do the quick way first. So if I go to my graph, it should cross the x-axis between 2 and 3, right? And I think it does. So then if I go to calculate, so second trace, and number 2 is 0. So if I want a left bound, now this is on an 83 plus. I'm gonna show you another technique if you don't have this kind of device. So first I'm gonna do a left bound, I'm gonna hit enter. I'm gonna go right of my 0. I'm gonna hit enter. And then I wanna get as close to the 0 as I can and hit enter. So this gives me that the 0 is 615, but that 5 tells me to round up, so 2.62. 2.62. Now, before I submit that, I want to show you how you can arrive to this conclusion without using that technique. So you can actually do this in a spreadsheet, but we're going to play with the table. So if we go to the table set, we want the table to start at 2. What's the time? Okay, and we wanted to change by 0.1. Okay, so somewhere between 2 and 3, we should get a sign change. So if I go check out my table, and we start looking at the outputs. You can do this in Excel or numbers, like a spreadsheet, and it'll be quick once you know what you're doing. So we see that between 2.6 and 2.7, we get a sign change, okay? So then let's go back to the table set, and instead of starting at 2.1, now we wanted to start at 2.6, and we wanted to change by 0.01. Okay, let's go back to the table. Oh, well, we know the answer is right, but let's go back to the table. And we want to look at our sign changes again. So we get a sign change between 2.61 and 2.62, right? So to decide that second decimal, we need to do this one more time. So we want the graph to start at 2.61. So I'm gonna go to table set, 2.61. And now we wanted to change by 0.001, okay? So now when we look at the table, okay, now we're looking at our sign changes. And we get one between 2.615 and 2.616. So in either case, both, if we round to 2 decimal places, these both round to 2.62. And we know that that's the correct result there, okay? Let's do one more. That one was a little bit intense. Let's just do one more and we'll call it a day. Same thing, intermediate value theorem. I want to show that the zeros between 1 and 2. So I'm going to go to my y equals. Let me see, I got my x hat 5 minus 3x hat 2, okay? minus 12. Okay, that looks okay. Okay, let me quit. So then I'm gonna go to table set, and you can do a similar exercise in like Numbers or Excel. Numbers is just a Mac version of Excel. And a lot of the concepts are similar. But you could put formulas into there, and so it's actually a calculator. Okay. So then let's look at the table and see if we get a sign change. So somewhere between 1 and 2, and right there between 1.8 and 1.9, the sign changes, right? So now we're going to get the table to start at 1.8. So I'm going to go to table set. We wanted to start at 1.8, and now we wanted to change by 0.01. Okay. So let's go back to the table. We're starting at 1.8. Now we're looking for another sign change. So on the right, they're all negative right there. It's between 1.86 and 1.87. So then now we get the graph to start at 1.86. So I'm gonna go here to table set, 1.86. And we wanted to change by 0.001. It's like we're zooming in with each iteration. If we go back to the table, now we're looking for the final sign change, and we see the sign changes between 1.862 and 1.863. So we know the zero is somewhere between those two, but both of these round to the same two decimal places, which is 1.86. So this one, we're going to submit 1.86, cross our fingers. That's more than enough. So again, we really didn't take copious notes, so I don't really think I'm gonna share the notes on this because it was really just that quadratic formula example. Are there any burning questions before we go our separate ways? Okay. The main thing is just you want to keep making your way through the assignments on Pearson, and that's it really. I think this is the full College Algebra one, so you don't have a lab. It's just the assignments on Pearson. If you're trying to improve your overall grade, you want to prioritize the exams. You can go back and improve them and earn up to 90%. Yeah, okay. If there aren't any other burning questions, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day, guys. Okay, take care. See you Monday, same time, same place. Peace.